Hello friends, in this video I will be talking about basic concept of photon and de Broglie wavelength, and I will discuss two important type of problems you may get in the exam, either in regular BSc course or in PGC. Concept of photon. Photon is nothing but an energy pocket. Energy pocket equivalent to h nu, where h is Planck's constant, nu is frequency of the light radiation. This can also be written as hc by lambda. Frequency can be written in terms of velocity of light c divided by lambda, because you know the formula c is equal to nu lambda. This concept was given by Albert Einstein in 1905 when he was explaining photoelectric effect. He said, if there is a light ray and this light ray consists of quanta of energy. Quanta means a minimum amount of energy, and that is known as quantum. And if there is a light, it will have n number of quantas. This will be equal to energy given out by the source, n terms of quantum. This can also be written as n h nu is equal to energy. So it is something like, we can easily understand this. If I have got 100 rupees in my hand, this 100 rupees can be told as equivalent to 100 times of 1 rupee. This 1 rupee is the minimum amount 1 rupee multiplied by n 100. So n quanta of rupees, like that. Here n quanta means energy pocket, that is equivalent to h nu or hc by lambda. To talk about any energy, that can be told in terms of number of quantas of energy. Now this nicely Albert Einstein adopted and explained the photoelectric effect concept. Now, from this formula, this energy pocket I will represent here as E. E is equal to h nu hc by lambda. Now this E is nothing but work done, W, from our basic physics, and work done can be represented as force multiplied by distance, and this force can be written as momentum by time according to Newton's second law. Rate of change of momentum is nothing but force. And I can also write this as P. This S by T can be written as V. So E can be represented as PV. Now this PV, this energy I will write here is equivalent to hc by lambda. Now from here, in place of V is nothing but velocity. Velocity I will write here, velocity of light here. So this equation I can write as Pc is equal to hc by lambda. And if you cancel C and C, I am left with P is equal to h by lambda. P is equal to h by lambda. This formula represents momentum of the photon. Momentum of the photon is represented by P is equal to h by lambda. Now, very important question one may get now. I am talking about light. I am talking about light here. Light consists of energy represented by this, and finally I got momentum of photon. I got momentum of photon is equal to P is equal to h by lambda. Generally, momentum, what is the formula for momentum? Momentum is nothing but mass into velocity. Mass is related to matter particle, mass of a particle. Now, here, lambda is connected to a wave. So, light behaves as a wave. At the same time, it can also behave like a particle since it has got the momentum. And this is the idea de Broglie got in 1924. He was a French physicist. He got the idea that even matter can move like a wave. Electron can move like a wave. That is where the birth of de Broglie matter waves started. So de Broglie got the idea of matter waves because a photon whose momentum can be calculated. Now we have got basically one formula is E is equal to h nu or hc by lambda. This is one formula. And the second formula is P is equal to, we got P is equal to h by lambda. And from here I can write lambda is equal to h divided by P I have got. And this lambda is known as de Broglie wavelength. De Broglie wavelength. Now, we are saying a material particle can have a wave nature. And this in fact verified by Davison and German experiment and G.P. Thomson experiment that electron behaves like a wave. But we are not discussing about those experiments here. These are the two experiments which demonstrated the concept of macro waves. Now, this momentum, I will write this h by, momentum can be written in terms of kinetic energy because we have got a formula. Kinetic energy is equal to half mv square. So this kinetic energy, if I represent this kinetic energy by V, half mv square. On either side, if I multiply here, if I multiply and divide by m, so m here, that m square, then this will become m square v square. I can write it as p square, this 2m. So p square by 2m is equal to kinetic energy. So I can write this. This implies P is nothing but root of 2me. Now I'll write in place of P, I'll write now here 2me. So de Broglie wavelength can be represented in terms of kinetic energy and the mass of the particle, and h is the Planck's constant. Now if you remember these four formulas, we can work out any problem connected to the de Broglie wavelength. Now we'll see first problem. Very simple problem, but very useful, important type of problem. Let us say there is one 100-watt bulb. There is a bulb. There is a bulb which is 100 watt. So 100 watt means power. Power of the bulb is 100 watt, and which is emitting a light of wavelength 590 nanometers. Now the question here is, question asked is, how many photons are emitted by the bulb in 1 second. So this is the question. There are many questions framed in this fashion, so I have taken one example. So there is a bulb, 100-watt bulb, which is emitting a light of wavelength 590, and how many photons are emitted by the bulb in 1 second. So to do this problem, we have, let us 100-watt bulb. So power is given. Power is equal to work by time. Work divided by time. In place of work, I will substitute hc by lambda. And this is nothing but whatever hc by lambda. So lambda I can substitute, c I can substitute, h I can substitute. I can write the power 100 watts in terms of this. So from there I will calculate how many photons are there. I will write here there are n photons are there. N hc by lambda is equal to power. So therefore I can write here n number of photons is equal to P multiplied by lambda divided by hc. So power is 100, lambda 590 nanometers 10 to the power of minus 9 divided by h 6.623 10 to the power of minus 34 joule second. This is joule second units, and C is 3 into 10 to the power of 8. And if you calculate this, if you simplify this, you will get 2.97 10 to the power of 20. This is n number of photons, therefore you get so many photons are coming out from a 100-watt bulb per second. See, in our day-to-day in our home also we can see if there is a 40-watt bulb, if there is a 60-watt bulb, and you take average wavelength, it's something like 590 or 500 nanometers is the average wavelength of the light, visible light which is coming out, and you can calculate per second how many photons are coming from the bulb. So it's very simple problem. Now we'll go to the next very important type of problem. Now in this case, an electron is moving with 120 electron volts energy. It is moving. Now, what is its de Broglie wavelength? That is the question. De Broglie wavelength has to be calculated. Now, de Broglie wavelength formula, just now I wrote, it can be written as h divided by root of 2m.E. Now, h value you write 6.623 10 to the power of minus 34 joule second divided by root of 2 into, here you put mass of the electron. Mass of the electron is 9.1 10 to the power of minus 31 kg, and E value 120 electron volts he has given. This 120 electron volts has to be converted into joules. So 120 multiplied by 1.6 into 10 to the power of minus 19. This is joules. Because 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. So why I am doing this in joules? Because finally whatever value you get, because this is in joule second, this is in kg, right? So final answer you will get in SI system. SI system lambda will be in meters. This quantity whatever you get will be in meters. And if you simplify this, you are going to get 0.112 into 10 to the power of minus 9. This is equivalent to so many meters. 0.112, you can call it as nanometers. 0.112 nanometers you will get for this. Unless you know this formula in terms of kinetic energy, unless you know how to convert this, you will not be getting the answer. This is very important steps in calculating the pattern. Now, in last year PGCET question paper, there was a question that if you take electron and proton, if they have same momentum, electron is moving with certain momentum, proton is also moving with certain momentum, momentums are same. Which has got more de Broglie wavelength? That was the question. So de Broglie wavelength lambda, you know that, by divided by P, and h by P is MV. Very simple to answer here. P, if you take the, see, h is constant and V is the velocity of the electron, velocity of the proton, let us say. Now they are saying same momentum means one's velocity will be more, one's velocity will be less. This m of proton is greater than m of electron. And in fact, therefore this implies, since in the denominator larger quantity if it is sitting here, then the lambda value will be less. This implies lambda of proton is less than lambda of electron. This is the answer. Same question. Instead of telling same momentum, we may also tell same kinetic energy. Both are moving with same kinetic energy, which will have more lambda value. So electron will have more lambda value. Lambda of electron is more, lambda of proton is less. So de Broglie wavelength of electron is more compared to the de Broglie wavelength of proton, because proton is more massive than the electron. So electron mass is 9.1 10 to the power of minus 31 kg. This is the electron mass of the electron. Proton mass will be, you should also remember this conversion factor, 1800 times more than this. will be the proton mass. So proton mass will be 1800 multiplied by 9.1 10 to the power of minus 31. You write here, you get the proton mass. So this is a very short video giving some important information regarding the de Broglie theorem. Thanks for watching my earlier videos and thank you very much.